Hi there, thanks for clicking on this video and welcome to this second part of the predicted paper for Pure Paper 1 Edexcel Maths A-Level exam, which is this summer on the 7th of June. Here's a list of all the topics that the exam board have said will be on the exam, but this isn't a list you should just be sticking to because the exam board have said that there may be other areas of the course that could be examined, but this is the main focus so that there's going to be no surprises when you sit that exam in the summer. So this is part 2. If you've watched part 1, that covered the questions from proof to differentiation. This video covers the trig identities to the vectors section. Now the exam board have said that the order they have given the list of advanced information is just the order from the syllabus. It's not necessarily going to be the order that the questions appear in the exam. If you are watching this video and looking at the solutions, I really suggest that you use the description of the video to download the PDF so you can have a go at the questions first and you have a look at them before you watch the solution, or as the questions come up, just pause the video and see what you would do before you watch the solution. If I could ask you at some point during the video, if you're liking the content and finding it useful, please give it a like and subscribe. The more likes it gets, the more people will get to see it. So let's get started then. The first question here, we've got a trig identity question. When you're trying to prove trig identities, you need to start with one side, manipulate it to obtain the other. And it's easier with this question to start with the right-hand side. This is just sort of qualifying and telling us what types of theta we can have. So we need to start with tan theta sine 2 theta and get 1 minus cos 2 theta. So I'm going to replace the tan theta with sine theta over cos theta, and then sine 2 theta, I've written the addition formula here that you get in the formula book, but how do we get sine 2 theta is when A and B are the same. So this would be sine A cos A plus cos A sine A. So you've just got two terms of the same. So this would be times 2 sine theta cos theta replaces the sine 2 theta. The cos thetas will cancel and we'll get sine squared theta, 2 sine squared theta. Now 2 sine squared theta appears in the identity that is equal to cos 2 theta, but cos 2 theta is 1 minus 2 sine squared theta. So we set this up as 1 minus 2 sine squared theta. Then when you put that minus into the bracket, the ones will cancel and you'll get plus 2 sine squared theta, which is what we've got. And this is the same as 1 minus cos 2 theta. So we've got there, we've proved the identity. Now part B, when it says hence solve, that means that you must have to use some of the information that you've got from part A to help you solve this equation that you've got in part B. So we can see that we've got the 1 minus cos 2 theta and we've got a 1 minus cos 2x, so we can replace that with the tan. Now because tan's involved and here we've got tan squared, I've got a feeling that if we replace sec squared using our Pythagorean identities, sec squared is 1 plus tan squared. So if we replace that for the sec squared, the 1 and the minus 5 will make minus 4. So that first bracket will be tan squared x minus 4. And then the second bracket using our identity from part A will be tan x sine 2x, and that is equal to 3 tan squared x sine 2x. Now if we multiply this bracket out, you're going to get tan cubed x sine 2x minus 4 tan x sine 2x, and bring the 3 tan squared sine 2x over would be minus 3 tan squared x sine 2x is equal to 0, and then we can factorize. Each term has got a sine 2x and a power of tan, so let's take tan x sine 2x out on the front and we'll have tan squared x minus 4 minus 3 tan x. So we're going to get inside that bracket a quadratic in tan. So these two terms times together are going to equal 0 when this first term equal 0, and what values of x will make tan x sine 2x equal 0. That in our range of x being between minus pi by 2 to pi by 2, so that's minus 90 to 90. Well, the only value there will be x is equal to 0. And then here we've got a quadratic in tan. So we can say tan x and tan x, two numbers that multiply to give us minus 4, and the signs will have to be different. So if I say plus 1 and minus 4, that should factorize that for us, and that's going to equal 0 when tan x is equal to minus 1 or tan x is equal to 4. So what values of x will give tan x equal to minus 1 when x is minus pi by 4, so minus 45 degrees, and then on your calculator inverse tan of 4, and it wants it to 3 decimal places, x is equal to 1.326. So they are our 3 answers. Got another trig equation to solve here. This time it's in degrees, so do make sure you can toggle between being in degrees and radians on your calculator. Again, we've got sine 2 theta, so we can use that identity that sine 2 theta is 2 sine theta cos theta, and we've got to solve this. So I'm going to do 5 times 2 sine theta cos theta for sine 2 theta is equal to 9 sine theta over cos theta. Replacing the tan, I'm going to cross multiply, and that will be 10 sine cos squared theta, and then bring the 9 sine theta over, minus 9 sine theta is equal to 0. Now usually when you're solving a quadratic, the aim is to get it all in terms of one trig ratio, but it doesn't really matter that we've got sine and cos, because we can take sine theta out. Should have a theta there, shouldn't I? And that will be 10 cos squared theta minus 9 is equal to 0. So now, because we've factorized, sine theta equals 0, or that bracket equals to 0, and sine theta equals 0 is going to happen in the range between minus 180 and 180 when theta is equal to minus 180, 0 or 180. And then just rearranging and letting this bracket equal to 0, we're going to have that cos theta is equal to the plus or minus the square root of 9 over 10. And then if you do inverse cos of that, and because it's the plus or minus because we're taking the square root, it's going to give us plus or minus 18.4 degrees and plus or minus 161.6 degrees. Okay, so part B, we're looking at something quite similar to what we've done in part A. We've got the 5, the 2x, and you can see here we've got the 9 tan theta and we've got 9 tan x minus 25. So we look at that x minus 25 and see if we can rearrange and put that in the same form on the left. We've got 5 sine, taking a 2 out, and then you'd have x minus 25 is equal to 9 tan of x minus 25. So it's looking more similar to what we've just done. We've just got this 2 here. Now the 2 there inside the sign is going to affect the x coordinates, and what's going to happen is when we do the graph of that left hand side, it's going to do half as much in the same period, but where these two graphs would intersect is going to be at the same place and have the same solutions as what we found in part A, and that's going to happen when x minus 25 equals the answers that we've got in part A. But we want the smallest positive solution, so having a look at all these answers, I think if we let x minus 25 equal minus 18.4, then the x, when we take that 25 over, is going to equal 6.6, which is going to be the smallest positive solution to the equation. So this is an area under the curve question, and we haven't got the curve described in a Cartesian form, we've got parametric equations. So when we're going to integrate parametrically, we need to integrate y with respect to t, because that's how we're given, but we must multiply by dx by dt, because then that will be equivalent to the dt's cancelling, and it will just give us y with respect to x, and therefore we'll be finding the area under the curve. So we need to find where this curve goes through the x-axis, because what will include the area is between these two places. That's going to be the limits of our integration. And where is this second place here? It's when y is equal to 0. So y is equal to 0 when 5 sine 2t is equal to 0, and that's going to happen when 2t is 0 or pi, thinking about your sine graph, and that's going to happen when t is either 0 or pi by 2. So they're going to be our limits of our integration, and then we just need to find what dx by dt is. Differentiating x is just going to be 6 cos t, and now we can fill all our bits in. 0 to pi by 2 of 5 sine 2t, which is y, times the differential of x, 6 cos t dt. And now we're nearly there, but we just need to use our double angle formulae. So that's going to be 0 to pi by 2 of 5 sine 2t is 2 sine t cos t times 6 cos t with respect to t, and then sort all your numbers out, tidy up. 5 times 2 is 10 times the 6, which is 60. We've got sine t and then cos squared t, and that's going from 0 to pi by 2 with respect to t. Now in part 2, hence show by algebraic integration that the area is exactly 20. So hence show, we've got this integral here that we've now got, so we must use that to actually do the integration to try and show that the r is exactly 20. So this integral is of the form where we've got f dash x, or nearly got it, times f of x, some function here, and then the outside function does have its differential here. So if we just concentrate on the cos squared, and when you are integrating you add a power and divide by the new power. So if I have a guess and think that this will be something to do with cos cubed t over 3, or you can put a third in the front. The 60 is just going to join in on the front, and then what will happen when I differentiate? I will power down, the 3 will come down and divide by the 3 on the bottom, and then it'll be cos squared t. That will be differentiating with respect to the fact that it's cubed, but then I must then multiply by the differential of the inside function, so the cos t, and that will be minus sine. Well, I do want the sine, but I don't want the minus, so I just need to put a minus in the front to compensate for that minus that's going to come when I apply the chain rule. And I need to go from 0 to pi by 2. Now all I need to do is put in my limits. So when t is pi by 2, which is 90, cos of 90 is 0. So the first limit going in is going to give us 0. The second limit, when t is 0, cos of 0 is going to be 1. The 60 and the 3 can cancel and just give me 20. So it's just going to be minus 20 there. And then the 2 minuses is going to give me plus 20 as required. So this is part B of the question we've just been doing on the parametric integration, and we had that x was equal to 6 sine t and y is 5 sine 2t. we've got this is a profile of a dam. The vertical wall of the dam is 4.2 and we've got a horizontal walkway along the top that's 4.2 meters high, and we've got to calculate the length of m to n. So what we need to do is find when y is equal to 4.2, what is the t? So let's let 5 sine 2t equal 4.2. So sine 2t is going to be 4.2 over 5. So 2t is inverse sine of that, and that gives you 0.997 and 2.145, because remember, you've got to use your sine graph. Your calculator's giving you that principal angle, and then you've got to come back from 180, which is pi, to get the other angle, and then divide by 2 to get that t is going to be 0.4985 and 1.0723. And then x is given by 6 sine t, so the x value at those 2 points is going to equal either 2.8687, which will be that point there, and then the other one, when we put that t is 1.0723, the other one will be 5.2698, which will be that point there. And then all we need to do to find the length of the walkway is take them away from each other. And if you do that on your calculator, you get 2.40, so it's 2.4 meters wide. This next question is an exponential modelling question. We've got n being the number of bacteria, and we've got this exponential model. We're being told that there's 1,000 bacteria at the start of the study. So at the start of the study, t is equal to 0. When anything in the power is 0, e to the 0 is going to be 1. So 1,000 is going to equal a times 1, so that is telling us that a is equal to 1,000. Now some more information is going to allow us to find what the other constant, which is k. So exactly 5 hours from the start, the population doubles. So if it started at 1,000, in 5 hours times it's going to be 2,000. So we know that a is 1,000, then it'll be e to the 5k. If we divide by 1,000, we'll get 2 is equal to e to the 5k, and then if we just take ln's, we'll get that the ln of 2 is 5k, which will tell us that k is equal to 1/5 the ln of 2. So the model is going to be that n is equal to 1,000 e to the 1/5 ln of 2 t. Now you can put that in your calculator and find numerically what 1/5 ln of 2 is, or just keep writing it as 1/5 ln of 2. Part B, hence find the rate of increase of the number of bacteria 8 hours from the start. Now as soon as you read that word rate, it's the rate of change with respect to time. You know you're going to be differentiating with respect to time. You've got to find out dn by dt. So if I do B here, we need to differentiate the model, so dn by dt. Now using the chain rule, when you differentiate e, you're just going to repeat the function, but you've got to compensate the fact that it's got this coefficient in front of t, so that will come down and times by the 1,000. So it'll be 1,000 times 1/5 the ln of 2 e to the 1/5 ln of 2, and you need to find what that is when t is equal to 8. So dn by dt, so if you just put all that in your calculator with t equal to 8, you will get out 420.8 0.24, and it wants it to 2 significant figures, so that's 420. So that's the rate at which the bacteria is increasing 8 hours after the start of the model. Now the next bit of the question says the number of bacteria in a second population M is being given by a different modelling equation, but you're told that the K is the same value as it is in part A. Given that T hours after the start of the study, the number of bacteria in the two different populations is the same, we need to calculate what that T is. So we just need to equate both of the models because at the same time they have the same amount of bacteria, and our K is 1/5 the ln of 2t, and that's equal to the first model 1000 e to the 1/5 ln of 2t. Now if we divide both sides by 500, that will cancel and we'll just get a 2 there, and then I'm going to cross multiply and take this e term down, so e to the 1.4 times 1/5 ln of 2t, and divide by that e term, which is just 1/5 the ln of 2t, is equal to our 2. Now using our rules of indices, what happens when you've got the number to the same base? You can just take away, and I've got 1.4 times this constant minus just 1 of that constant. So if I've got 1.4 of something and I'm taking a whole one, I'm going to get e to the 0.4 times 1/5 ln of 2t is equal to 2. Now if I just take ln's on both sides, I'll get 0.4 times 1/5 ln of 2t is equal to the ln of 2. And I can cancel by ln's on both sides because on the left they're all times together. And then I can just say that t is going to be cross multiplying 5 divided by 0.4, which is 12.5. Okay, the next question is some differentiation, and we're going to be using the quotient rule. So y is equal to 4x squared plus x over 2x to the half minus 4 ln of x. Dy by dx. Quotient rule is bottom differential of top minus top differential of bottom all over bottom squared. So we need to do bottom 2x to the half differential of top, which is 8x plus 1 minus top 4x squared plus x differential of bottom. The half will come down and cancel with the 2, and we'll just have x to the minus half, and then that'll all be over bottom squared. 2 squared is 4, x to the half squared will just be x, minus then 4 ln of x will differentiate to 4 over x. So let's tidy up and multiply this in. We're going to get 16x to the 3 over 2. You add the indices. This is x to the 1 plus a half is 3 over 2 plus 2x to the half minus, now you're going to multiply this in, so 4x squared minus a half will be 4x to the 3 over 2, taking them away, and then it'll be minus, because this minus will go in and make a minus here, and we'll have x to the 1, and then take away a half will be x to the half. Now minus, I'm going to give this second term here the common denominator, so make that 16, and then I can have it all over the common denominator for x. Then looking where I'm trying to head towards, I've got the 4x on the bottom, but I need a root x on the bottom. So if I times top and bottom by root x over root x, like when you are rationalizing the denominator, it's not going to change the value, but it's going to give me the right denominator. And then I'm going to multiply all of this top by root x and start writing it in root form so I can try and get my answer. So 16x to the 3 over 2 times x to the half and the 3 over 2 will give me 16x squared, plus the 2x to the half times the root x will be 2x, and then I've got the minus 4x to the 3 over 2 plus x to the times x to the half. You're going to add the indices, so that will be 4x squared minus x and minus 16 root x all over 4x root x. So now if I just tidy up, I've got 16x squared minus 4, which is going to give me 12x squared. I've got a 2x minus an x, which is going to give me plus x. I've got a minus 16 root x, and that's all over my 4x root x. Okay, on to part B. We've got figure 1 with P being the minimum point of this curve that we've just differentiated, and we're to show that the x coordinate of the minimum point is given by this thing here. So when we have a minimum point, the differential that we've just found is going to equal 0. That's only going to equal 0 when the numerator is going to equal 0. So 12x squared plus x minus 16 root x is equal to 0. Now what I can do is take root x out, and I'll have 12 to the x to the 3 over 2 plus x to the half minus 16 is equal to 0. Now, as two factors, either the root x on the front is going to be 0. Well, that's not where it is, isn't it? And x, at the beginning of the question, we're told that x has to be bigger than 0. So this is not going to give us a solution for our minimum point. It's going to have to be when this bracket equals 0. Now, what they've done is use iteration to try and home in on one of these x's. So what they've done, you can see by the 2/3, it's kind of like this term here turned upside down. So if we say that 12x to the 3 over 2 is going to equal 16 minus x to the half, or root x, and then we'll get x to the 3 over 2 is equal to 16 over 12 minus, if I just write that as root x over 12. So x to the 3 over 2 is equal to 16 over 12 is 4/3 minus root x over 12. Now to undo this 3 over 2 as a power, if I just take raise each side to the 2/3, then it has the effect of cancelling on here to just give me that x is equal to 4/3 minus root x over 12 all to the 2/3. So using this iteration formula, that's going to tell us what the next one along is going to be, starting with x1 is equal to 2. So on your calculator, you need to feed in 2 and have it in the bottom of the display, and then use the answer key to key all of this in. And instead of xn, just type in answer there. And if you do that and get x2 on your calculator, it will be to 5 decimal places 1.13893. And then if you keep pressing the equal sign, it will do further iterations, and then you just keep pressing it till it settles down and you get an answer that repeats itself for 5 decimal places, and you find that P is equal to 1.15650 to 5 decimal places. The next question is an integration question being asked with the integration as a limit. So this is where integration comes from first principles. This has appeared on exams before. People didn't realize that all you need to do is integrate. So this is equal to the integral from 4 to 9. Root x is the same as x to the half dx. So that's all you need to do to get the answer. So we're integrating between 4 and 9 of root x. Then what do we do to integrate? Just add 1 on, divide by the new power. So that will be x to the 3 over 2. Divided by 3 over 2 is the same as timesing by 2/3. And we need to do that between 4 and 9. So that's equal to 2/3 times 9 to the 3 over 2. And we need to take away 2/3 times 4 to the 3 over 2. Now 9 square rooted is 3, 3 cubed 27, 2/3 of 27 is 18, minus 2/3 times 8, and that is equal to 18 minus 16 over 3, which is equal to 38 over 3, or 12.6 recurring. This next question is a method of integration, and we're going to be using substitution. So you can see that the substitution is 1 plus root x, which is going to replace that denominator. But in order to substitute, we need to replace the limits, we need to replace everything. So that's the numerator of that fraction, and we need to replace the dx. So let's do the limits first. When x is equal to 0, u is equal to 1 plus 0, so that's 1. When x is equal to 16, u will equal 1 plus root 16, which will be 5. Now let's say u is equal to 1 plus root x. So rearranging and making x the subject, u minus 1 all squared will equal x. So that will replace the numerator of that fraction. And now if we differentiate this, you're going to power down on that bracket, take 1 off and multiply by the differential of the bracket, which is 1, using the chain rule. And what we can do is just cross multiply. The dx is going to be replaced by 2 u minus 1 du. So we've got all the bits and pieces to now apply the substitution. It's going to go from 1 to 5 of x, which is u minus 1 all squared, all over our u times our 2 u minus 1 du. And then just tidy that up. It's going to be 1 to 5 of 2 u minus 1 all cubed all over u du. So we've got it. P is 1 and Q is 5. Part B, we need to hence show that this integral is equal to a minus b, the ln of 5. So what we can do, instead of integrating, we can just use all of this and just stick to keeping everything in terms of u. We don't need to transfer back to x. We can just now integrate between 1 and 5 in terms of u. So what I'm going to do is take the 2 out of the integral and go from 1 to 5 of u minus 1 all cubed over u du. Now you can multiply those 3 brackets together, or you can use the binomial expansion to say that this is u cubed minus 3u squared plus 3u minus 1 all over u du between 1 and 5. Now divide that u throughout all the numerator. So dividing by u on the bottom is going to give you u squared minus 3u plus 3 minus 1 over u du between 1 and 5. And now we can integrate. So 2, and we're going to get u cubed over 3 minus 3u squared over 2 plus 3u minus the ln of u between 1 and 5. Put our limits in. So 2 And let's have some round brackets. So 5 cubed, 125 over 3 minus 3 over 2 times 25 plus 3 times 5, 15 minus the ln of 5, and then put the 1 in. 1/3 minus 3 over 2 plus 3 minus the ln of 1 is 0. And then if you put all that in your calculator, it comes to 2 times 52 over 3 minus the ln of 5. If you just multiply that 2 in, you're going to get 104 over 3 minus 2, the ln of 5. So our A is 104 over 3 and B is going to be 2. Just to finish this video off, just a quick question on vectors. You are told that P, Q and R have positions relative to an origin and they all lie in a straight line from the origin. So P, Q and R. Now the vectors to get to each of them are P, Q and R, but we're told that Q lies 1/3 of the way from P to R. So if we get to Q, we can get to P, O to P, plus 1/3 of the vector from P to R. Now P to R using reverse vectors is just going to be R minus P, and O to P is P, so Q is equal to P plus 1/3 of R minus P, which is equal to P plus 1/3 R minus 1/3 P. A whole P minus a third P is going to equal 2/3 P plus a third R. And then if we take a third out as a factor and just write it in the order they want in the brackets, R plus 2P. Thanks for watching. Thanks for staying in. If you're still watching by the time you've got to the end of the video, do like and subscribe if you found it useful, and keep an eye out. I'll be making some more videos to help you with your revision for your exams this summer. Thanks for watching. See you on the next one.